I apologize for the brief moments of panic here, and I will have to apologize again later because I ended up doing some late night coding last night. Always a really good idea when you're working on the system you're about to demo the next day. So yeah, I broke one of the demos, and then I fell asleep with my computer on. It powered off, which virtual machines in Linux doesn't like. So I don't actually have a graphical system to demo anything for you. It doesn't really matter because I'm not actually a graphical user interface kind of guy. And I can still show you that that what I'm working on works. I can prove the point, so to speak. Yeah, it's one of those things I do sometimes when I'm really clever. Okay, I'm going to be talking about Naemon, and I'm going to involve some nostalgia in this as well, because it will give a little background to why we're doing what we're doing. My name is Andreas Ericsson, and this is my email address in case you have questions that you have to ask after the presentation. The agenda starts with the agenda. Very good. Ego slide, where I introduce myself. About OP5, they're sponsors of Naemon and also my employer, so I always have to put that slide in there. IT now and then, this is where we get to the nostalgia part. I was actually doing some looking into like history of computing, and I got the feeling that the Hitchhiker's Guide to the Galaxy, when he claims that it was probably a bad idea to climb out of the trees, is like, whenever I look at all the problems we have to solve with IT now, I feel that every 5 or 10 years we have one such like crossroads. It's like, oh, this was, yeah, looked like a really bright idea, but my God, how many problems that has caused. Then we'll get into the actual juicy stuff with Naemon, roadmap progress up and coming, and stuff that I'm working on right now, including some console demos, because, yeah, user interfaces don't really work today. Ego slide is about me. I've been programming since I was about 7, when I got a Commodore 64 instead of an electrical piano that I actually wanted. So I had to start writing. In those days, you got a manual about this thick with a computer, and it was full of program listings. One of them let you turn the keyboard into a piano. So naturally, I had to try that. You couldn't really save back in those days. So I had my computer on, hooked up to a small TV for 6 days while I like copy-pasted from paper onto the terminal. It didn't work, of course, because writing a program of about, I don't know, 6,000 lines, even if you just copy-paste it, is bound to have typos. So I had to learn to debug programs. I started doing that when I was 7. I was not exactly a normal kid, but I had a lot of fun. I'm a core architect at OP5 since 2003, and today is actually 11 years ago exactly since I went to OP5 to work there for the first time. After my insanely good hiring interview, where I came in a towel, a t-shirt, and flip-flops because a cat had just peed in my suitcase in Barcelona. So yeah. I was an Agios core developer between 2009 and 2013. I'm a bit of a performance fanatic, which you can see in most of the stuff that I do. And if you've seen the difference between Nagios 3 and Nagios 4, and, well, Nagios 3 and everything that came after it, then you will know. I'm the author of Merlin and, well, Nagios 4. I am also the Naemon maintainer. I was once voted most likely to invent the lightsaber and then accidentally killing himself with it when we last played a particular drinking game, which I'll be happy to teach you after the conference. The motivation here is that he does a lot of dumb shit, but he's pretty smart on the inside. I'm still not sure if that's a compliment or an insult, but I'm going to take it and run with it. I'm sure it would make for an awesome line on dating sites or something. About OP5, this is actually not accurate because I just copied it from last year, but yeah. About 1,000 customers. We have very high renewal rate. We focus on large installations. Most of our revenue, well, most of OP5's revenue, I'm actually here in in my capacity as a Naemon maintainer rather than as an OP5 employee. But since they're paying for the trip, need to have this slide. It's very important. Most of our revenue comes from very large customers. Ericsson, well, sites where you install to monitor 1,000 servers or more with a single instance. I think our current record is something like 18,000, and it's getting bigger. You can find out more if you go to op5.com, where the user interfaces actually work. This is a pretty cool guy. This is John Mad Dog Hall, who I ran into last year at a conference in the US. I was actually, when I talked to him there, I wanted to do this IT now and then thing because, wow, things were really different a couple of years ago. Well, not so a few years ago, but still. So let's dive into it. This is going to be an explanation of why we're doing what we're doing, why this conference is actually required, and why monitoring software at all is required. And it really wasn't like that once upon a time. So, yeah. IT, circa 1970. Computer performance was as often measured in CPM, which is cards per minute. How many punched hole cards could you process per minute? As often as in megahertz. Computers were starting to become what they are today, but it was still a ways off. You had 1 year of training before you were even allowed to touch a machine or go. It's like they showed you where it was, but you couldn't actually put any cards into it. There was also a prank you could do where if you punched away all the holes on the card and then put it into the machine, it would just jam because the cards would get so flimsy that they would break. So you could do that if you wanted to just mess with your fellow students. Unix development began. This was actually to create a multitasking multi-user system in spite of all the other good things it provides, because the admin to computer ratio was about 300 to 1. And that's because everyone who studied computer science or did anything like that had to learn how to administrate their computer or manage it, take care of it when things went wrong, before they were allowed to do anything else. So having a multi-user system turned that one computer into something that a lot of people could use. It was first successful ARPANET test. This is one of those climb out of the trees moments. I mean, come on. You can't really hook computers up together and expect things to get a lot better. Computer-powered devices per person, I thought I removed that, but it was a metric I found for a few of the years that I was looking for. About 1980, one-man computers were gaining ground. So like the start of the PC era. Pac-Man was invented 1981, I think. Portable computers were being developed, and actually the first portable computer weighed 23.6 pounds. It had a display of 5 inches. How many in here has a cell phone with a display with 5 inches or more? Yeah, does it weigh 23.6 pounds? No. Okay. So Ethernet standards were introduced, another really good idea. The different networks, there was no internet still at this time, but there was like ARPANET, BitNet, Computer Science Net, and they all began merging with the emerging Ethernet standards. So this is the reason why we have TCP/IP, because they needed a common protocol to talk between the networks. Once you had TCP/IP, which is actually a really, it's a pretty solid piece of work, those standards. SMTP and DNS quickly followed. The average CPU speed was about 8 megahertz. Impressive. The admin to computer ratio had dropped to 10 to 1. There were still a lot more administrators than there were computers, but nowhere near as many as 10 years earlier. IT about 1990. This is where we're getting to the area where a lot of people here have personal experience. The IBM PC style computers were becoming popular. So were user interfaces, and I have a strong feeling that those two went hand in hand. The first web page was created 1992, I think. Pretty useless to have just one web page, because search engine optimization doesn't really work when there's only one web page on the internet. Linux was invented in 1991, and the internet had suffered its first worm already, which is called the Morris worm. It came in 1988 and infected like 84% of internet. Software installation was actually part of a job description instead of something that computers did on their own, more or less. Average CPU speed was around 66 megahertz. This was in the what were they called? I don't remember. Screw it. Admin to computer ratio was about 1:1, and everyone who tried to install a video game back then knew that you had to do, it was a 3-day process. So going to a LAN party wasn't just like picking up a DVD and going there. You started on Wednesday to get your computer set up if you wanted to play. What did you play back then? Warcraft 1 maybe? I have no idea. What? Yeah, oh yeah, or probably the 10 floppy disks that you needed. Yeah. Good times. In about 2000, we started to get Wi-Fi standards. We didn't really have that until 1998, I think, or there was Wi-Fi, but there wasn't any standard for it. So if you bought a Wi-Fi card, you had to make sure you got your Wi-Fi access point from the same vendor, otherwise they wouldn't talk to each other. It was the .com era, and Google finally overtook Alta Vista as the most popular search engine. This was 2001, I think. It was starting to get okay for non-nerds to get computers. This was a kind of a big step if you look at it from a social psychology standpoint. Nagios development starts and monitoring starts to become a thing. The average CPU speed was around 800 megahertz. I could be a bit off on that. It feels a bit high to me, actually. And the admins to computer ratio was about 1:10. So now we're starting to have admins that administrate more computers than there are administrators for. It wasn't just a case of, oh, I have these servers. I have this server. You don't just have a mainframe anymore. IT about now. Well, an average smartphone has 120 million times the computing power of the first general purpose computer, which was the Ferranti Mark I, according to Wikipedia. An average smartphone also has 4 million times the amount of main memory. The Ferranti Mark I had 512 bytes stored on 8 cathode ray tubes that were roof to ceiling size. Pretty good. Average CPU speed, I think 2.4 gigahertz, something like that. They ran into some issues with creating gold channels that are smaller than 50 atoms or something, so we're about to hit the roof there. The admins to computers ratio is about 1 to 300. This isn't necessarily true, but in large corporations or with data centers and stuff, this is generally a ballpark number that is somewhat correct. So, moment of truth. Hands up if the number of servers you manage has grown faster than the staff you have to monitor and manage them, or if you use more than 2 tools just to manage your servers, or if you have people dedicated to managing the servers that monitor and manage your servers. Does anyone recognize this? Yeah, okay. So I'm not just completely on a wild goose chase. So, conclusions then. Manpower is getting really scarce. It's like we don't have enough people to handle our computers. It means sharing resources is more important than ever. The most expensive resources are, of course, the most important to share. Using what works now, but doesn't lock one into a corner, is very much key to remaining effective. You don't want to end up using, well, if you were to lock yourself into Alta Vista in 2000, you would be really screwed over today. Developers obviously have a duty to minimize the job they do, because laziness means effectiveness, and laziness is important, therefore. We also have a duty to minimize the job that sysadmins have to do, because if we don't, then Skynet will become real by 2016, and who really wants a Terminator at home? They're not nice. Keep stuff simple. If it breaks, you not only get to keep the pieces, but you get to do the same job again in a different way, or solve the same problem at least. So with this in mind, how IT has developed, I was looking at this because I was looking over the roadmap, how it has changed from 2005 about to today. So with that in mind, having programs that manage servers, talk to each other, means that it's an important feature. Last year's Naemon roadmap was, it looked about like this. External commands via query handler. This is important because you need to be able to get a response from your monitoring system if your command has been processed, if it was malformed, or if it succeeded, or what happened with it. Drop dir support, because Chef and Puppet needs to be able to install modules and add-ons and make modifications. Live status, because using anything else is stupid. You should not do it. In progress, the check result transformer, if anybody remembers. I will be talking a bit more in detail about these as well. Object creation and modification at runtime. Scheduler controlled helper daemons has been changed a little bit since then because we came up with a better idea. 2 ideas have been scrapped. Runtime modifiable main config. We haven't really found a use case for it. We haven't found a single instance where you actually want to change the main configuration. So no one has been working on it, and we're just going to drop that one. Could be that we'll get it, that we'll do it some other time if we end up having to tweak variables for it for some reason. And object extensions, this was an idea that I had that would replace custom variables, but every way I come up with it, you need to have a way to represent them and to configure them. So it turns out to be custom variables after all, and they sort of fill the same role anyway. So I went with the laziness principle here. If it's already there and kind of works, don't mess with it. Up and coming. Backlogged since last year, runtime object creation and modification, which I had completed yesterday morning and then broke again last night. So you can do it with contacts, but services will cause core dumps. Check result transformer, scheduler control helper daemons. We also have performance data handling, which is completed. Something called active agents. Report data export. And all of this is because, well, because of this YouTube video. I'm not going to show it to you. It's about 2 minutes, and it's just a commercial for a company called Ericsson, which are building new data centers. They're going to monitor 100,000 servers using Naemon as their backend. And when you go to scales like that, we need to use other tools than our built-in tools to create reports, because it doesn't really, our stuff doesn't really scale that high. So they want to be able to get report data into Crystal reports. They want to use their own graphing solutions, which they bought for $10 million or something. I don't know. They have really expensive toys. But when you're building data centers on that magnitude, you're kind of spending a lot of money already, so I guess it doesn't really show up. So, runtime object creation and modification. I really suck at user stories. I haven't gotten the hang of, like, you have to have a certain format on them. So, but this is how I think of it. If users prefer to configure their monitoring on the monitored hosts, we should automatically add them to the monitoring config without necessarily reloading it. Because reloading configuration is actually stopping your monitoring system is something that is forbidden by certain standards, and especially governments in Sweden are really, really picky about following standards. It's like, oh, we can't do that because it's down for 0.4 seconds. It violates this rule set that we have to follow, otherwise we won't get as much money from the government next year. Really, really weird. It's added as a query handler extension, which sends a housekeeping event every X seconds to all the other modules that may also handle objects so that they can update their tables. This, like in the user story, allows new stuff to call in and start getting monitored automagically. Object creation may not happen if I can't get it stable in a reasonable time frame, because config reload is super fast nowadays. And we kind of get around the downtime thing by having redundant servers, so that one falls over. But the last point is kind of moot, because I have gotten it stable. It's just that I broke it again last night. The problem was that service escalations didn't get copied when you cloned a service. I spent a lot of effort on that, and yeah. I don't have any services with service escalations in my demo config, so it wasn't actually a problem, but I'm anal retentive sometimes and broke it. Assuming we have some time, I can demo this for you. Check result transformer. The user story here is that since anomalies in network and application behavior often indicate errors, or there's something you want to know about, is this program doing something it didn't do under the same load last time, then we need to know about it. So we need to be able to detect and notify about it. So it works really simply, actually. An external helper connects to NERD, which is the Naemon event radio dispatcher. It's it's a way to stream events from inside the Naemon core to helper applications that live outside the Naemon core. It lets you do things in other languages than C. It lets you do things without having to write modules that potentially jeopardize the stability of the core. We just feed it data in an easily parsable format, and then the external helper can do whatever it wants with it. So the events zip to the helper. It can alter the state, output, performance data, or whatever. And the helper zaps the results back to core via the query handler, which is a little bit like the command file, if anybody's used it, except that it's a Unix domain socket, so you can actually have two-way communication, and you can get a response saying, oh yeah, I got your message, and I'm processing it right now. Or it can say, you did something wrong, which means that you did something wrong. This allows for adaptive thresholds, which could be the topic for a whole presentation in its own. And the monitoring system requires little or no configuration. If you have a certain type of service that you know should remain more or less stable, like CPU load is one of those metrics that is reasonably good to use here. If you have CPU load average over, or system load average, you know that at certain points during your week, when you're running backups, when you're generating reports, when you're doing batch processing or something, the system load should be higher. If you have a deviation from the normal system load on some systems, you want to get alerted by that. Even if it means that, oh, system load is 0 on our machine that is supposed to do a lot of batch processing right now. Like, that's a deviation from the normal. It doesn't really fit into how we configure thresholds today, because we normally just say, oh, if system load is above 5 or 10 or 20 or whatever, that's really bad. But it's not necessarily the case. It could be really bad if system load is at 0 when you're expecting it to be at 10, because why aren't you doing work? So with some initial setup, it means that you can have very little or even no configuration forced on you afterwards. This is especially true for the very, very large setups, where you have data centers where, like Amazon, all of their servers are more or less exactly the same. They're identical. They run the same software. They run the same everything, because it's cheaper for them to buy 200,000 servers of the exact same kind, and it's cheaper for them to just replace one when it breaks with an exactly identical one than have a possibly slightly different one. You don't want to have, when you run really large data centers, you want most servers to be pretty much exactly the same. This was inspired by a piece of software called BizCheck, written by a guy named Anders Hall, who has been here and given presentations about it. And we will most likely end up using it as the engine. Excuse me. Scheduler-controlled helper daemons. The user story here is that users must be able to trust that exported data is complete. Whenever you have a data producing system that streams data to you and you connect to that system after it has been started, that means that you're not really sure if you missed any events before you connected, and it can't stream anything to you unless you are connected. So it's a bit of a, it's a conundrum. The new twist here is that Naemon will connect to other systems' sockets instead. So you can tell it to, like, oh, go here and make sure you do some sort of handshake. This will most likely be implemented as a module. I know that there's a guy at OP5 working on something similar, because working on something like this. Because modules are a really nifty way of extending things without putting features in there that that not everybody necessarily needs. Performance data handling. How many here use PNP? Okay. Oh wow, that's a lot. The way that PNP gathers performance data is normally by writing a lot of it to spool files and then batch processing it to update a lot of RRD cache, or a lot of RRD files, or sending it to RRD cache D. RRD cache D performs, I think we measured it to 1100 times better with regards to IO load, so you should be using that. But still, all the spool files generate a lot of unnecessary disk load. And if the batch processing somehow stops for some reason, we had one case where it just crashed. Nobody noticed because no one was watching the system. It was one of those unfortunate times when it was in a. It was actually a Chinese what are they called? Phone operator. They do network. They take care of the antennas and shit. What? Yeah, telco. Thank you. So they had a monitoring system in one of their tool sheds, which was standing way out in the rural areas of Tokyo, I think, somewhere. I don't really know. And the performance data processing stopped, but they had no way to remotely manage this system, and it had a database for hooking up. Okay, I'm getting hazy now because they didn't really tell me everything about it, but they had a database there that was doing something which was very, very important to keep the antenna and all the equipment that made sure that the 3G GSM networks kept working properly. So when we filled up the hard drive, their database stopped updating, which was pretty bad for them, and they had no idea why. But it's not really a good idea to write a lot of spool files. So the performance data handling stream can feed data to PNP or graphite. It gets rid of the last synchronously executed system call inside Naemon, which is really, really good. The major benefits from one of the major benefits from NETWAYS 4 is that everything is done asynchronously, which means that we can fully leverage the power of multi-core systems. Multi-core CPUs, multi-CPU systems. This is already completed, and I wonder what happens now. Oh, I can't tab out of this. How delightful. Woohoo! Okay. I don't know how to do that. Yeah, of course I can. Really? this is going to take forever. I need to increase my... Oh my god. See, this is what happens when you fuck up your demo system the day before you have your presentation and then fall asleep. Oh wait, we skip Valgrind as well because it's... Oh dear god. So, how's everyone doing? Changed your underwear today in case you get run over by a bus? Good. Oh dear god, why did I ever stop this? Once I had it running. So, how many here are really interested in seeing how this looks from a console perspective? You are? Okay, maybe we can do like this, I show you later, because we will have some time before lunch, and then I can do the keep going with the presentation for the people who prefer that. Yeah, I'm really good with user interfaces and stuff. The performance data handling design is really stupidly simple. And that's pretty important, because if it's complex, that means it's less robust. So inside Naemon, there's this thing called NERD, the event radio dispatcher, which is the only thing it does is when you register for a handler, when you register for a channel, that channel knows which events it needs in order to produce the data that you want. So you subscribe to a channel, and whenever an event like that is triggered, it could be because a host check just completed, or because downtime just started on a host, or a service, or we sent a notification. Whatever, really. We get a lot of information about that event as a callback. So it calls our function. We have a list of our subscribers, which hopefully are still connected. We produce some text and send that. It's mind-bogglingly simple, but that means that it works. It works really, really well. So you can ship this data to PNP or Graphite or, well, whatever you want, really. Usually by means of a small helper, because that means we don't have to handle 10,000 different formats inside Naemon. So you write, normally, I have written a little helper for this to put performance data in a MySQL database. It's 13 lines of Python code, I think. Oh no, 15, because user bin Python and then the empty line as well. So yeah. It's 15 lines code. Really, really simple. Active agents. This is where things get really interesting, actually. So the user story here is that Naemon should scale to as close to infinite sizes as possible. Of course, we'll never get to infinite sizes, because when we get there, infinity has moved on one step further. That's the problem with infinity. We never get there. To save time, new hosts should report what metrics they're offering, and Naemon should automagically monitor them. This is to save time? To save administrator time. So new hosts should just report like, okay, I have these and these services. Here are the metrics for them. Apache has had this many connections, and this many page faults has occurred in the kernel. We have had context switches all day long. Here's how much we're swapping, here's how much we're doing whatever. The way we solve this is either with using collectd. If you're familiar with Graphite, collectd is a pretty cool metrics gathering system, which has a support for a surprisingly large number of things. You can monitor things like Apache, Apache connections and faults and errors and how many status requests, and you can. There's an additional plugin that you can use for. It's pretty cool. Just check it out. This will serve as the input for the automagic host and service creation, which means that you don't really have to do much configuration. Or if you want to be a little bit more cautious about it, you use that input and stash it in a database somewhere, and you just when you want to. And then you can have the system say, oh, hey, we have new services and hosts available to monitor. And you have to click something, and then they start getting monitored. This means that you don't really have to do much of, you don't have to do much auto detection. I'm sure Remo can tell you how much fun it is to try to auto detect services. The author of NETI here. How much fun it is to auto-detect services that run on a closed box, because they might be running MySQL, for instance, but only on the local host, so you can't really see it from the network. This is a way around that, so that so what remains for auto-detection is the network topology, which is pretty tricky to do, but I think you're going to demo that or talk about it. Yeah, okay. It's tricky to do, but it's something that auto detection software should be left with, because auto detecting services that are running on the hosts it's really difficult, because there are so many different ways you can do it. As soon as you set up Apache on a different port than 80 or 443, auto detection software is like, what the hell is this? It's running on 5439. I don't know about this. Well, unless they're clever and actually ask the thing they're talking to. A really good benefit about this is that large providers already write and ship compatible plugins. In the case of checkmk, it basically just runs a lot of shell scripts, a lot of shell commands that give you information about the system. So it runs like df or tails out the /proc/mem file, it gets you all the raw output normally, and then you have something on the receiving end that parses it and does something sensible with it. But for collectd, for instance, Amazon already provides plugins for their services where we can fetch metrics for it. I think Google does as well. I'm not sure. But I know that you can get out those exact metrics that you want from their APIs, and it's easy to graph them once you have them. It also improves security in many setups, especially when you compare it to NRPE. One major feature of this is that both collectd and the pushing version of checkmk can send their data to a web server, to just a web service that takes the packet and handles it, and then you get all the security with certificate-based authentication and encryption and yada yada yada, which is a lot better than NRPE, which has a hard-coded crypto key. Always good. It also allows us to reuse a lot of existing code, which means that we can be really lazy and do a lot less work. I like it. And you should too, because, well, it's really nifty when you start building on things that a lot of people are already using and that has proven to work well. Because when you don't really have to debug those parts. If no one else is having problem with it and you can be pretty sure that your problems are in the remaining 50 to 20 or 80% that you're writing. So you get to just. Okay, we're getting data from here. That's good. So we don't really have to bother about it. The way this works, though, is a little bit different. It's a little bit more complex than just streaming data to a different program. So these are, for instance, different collectd instances on remote servers. They send all their data to a receiver or evaluator, which can sit behind a. Did I really just point on my own screen? I did. Send it to a receiver or evaluator, which can sit behind a web server to provide you with all that goody-goody certificate-based security. This receiver or evaluator, when it starts up, talks to live status, to find out which hosts and services already exist. The hosts and services that exist can have a custom variable that says metric, and it can say warn, and it can say critical. On those metrics, it can, for the warning and critical values, it can say, as usual, higher than 10 or lower than 5. Yeah, okay, that's warning or critical. But you can also say deviates. I'm a bit hazy on the syntax that I added, but I did have the thing I was originally going to demonstrate for you was a check which I added called internet morality, which was checking the ratio of porn to non-porn torrents on the Pirate Bay. And the idea was to send a notification when internet morality went above 40%. So it's actually surprising how many non-porn torrents there are, but like some... Yeah, because it still holds true that more than 2/3 of all the traffic on internet is porn or spam. That's how we use this great invention, ARPANET, from 1980. I'm sure their inventors would be proud. But apparently TV shows are very, very popular torrents. So Sons of Anarchy, Game of Thrones, Big Bang Theory. So every day there is one of those 10 major shows coming out. You get 20 or 30 torrents with the same episode that come out, and they always end up in the fresh or top 100 list. So yeah, porn, not as popular as you might think. So anyway, when it deviates, which it does on Sundays, then it rises. Internet morality goes way down, probably because of the crushed dreams and hopes from Fridays and Saturdays. So yeah, the idea here was to show you that when we fetch the configuration, which has these custom variables, and then we get the metrics from here, which are actually which you can aggregate if you want to. So you can have one metric for your collectD shows you, for instance, metrics for CPU. I have 4 cores in my laptop, so it gives me 4 metrics per core, which is a little bit wasteful. It needs to be aggregated because I don't really care which CPU core is doing a lot of work, so long as I have some power to spare, or that not all cores are just pegged. But we can do aggregation either in collectD, if you configure it for it, or we can do it in the receiver as well, because I added that feature before I realized that it was already in collectD, because I'm clever like that. Once we've received the results, we pass the final results to the query handler as an external external command, which is basically a passive service check. Or we could also register as a worker if we wanted to, and just not really care about the check requests that we get from the Naemon core. An option here, which I haven't added yet, is to add the metrics that add the possible services that we could have created to a database, and then add a user interface, which will just show you that, okay, this system has reported in, it provides metrics identical to that system, so maybe you want to clone that and create the same services. I have added a feature that causes it to auto-create hosts and services, but the number of metrics you get from collectD just makes it ridiculous. If you turn on the default plugins, you will get 78 services for each host that you're monitoring, because, well, it's not complete, it's in progress. So all the aggregation rules and aggregation defaults aren't in place yet. Does anyone have any questions so far, by the way? What? Yeah, this is the collectD network protocol. I started writing this with the collectD has an output plugin called Write Graphite, I started using that, but I will most likely change to use the web service-based one instead. Because one problem is that Collecti doesn't really order its output. So you can have delay between you get the first CPU -0 idle line, and when you get and you can have all the other metrics in between you get the CPU -3 idle, or whatever the metric is called. So I will most likely move to using a web-based system. It's also not really feasible to maintain that many open sockets, because this would using the right graphite plugins, these would remain connected to the monitoring system. And remember that we're trying to scale this to 100,000 servers, which really won't work. So either I will have to use UDP, which is potentially unreliable. It could still be that we end up going that route just because of performance reasons. UDP outperforms TCP by a long shot, because because it doesn't care if the packets they send are received or not, which TCP does. So it's but going for a web service is the most likely way to start, at least. And if that turns out to be not efficient enough, we may go UDP with this. So yes, that's one way of doing it. Right. Report data export. The user story here is that a lot of people want to use really fancy report creation tools, but it's pretty, well, sometimes it's pretty hard to do that, especially if you have to dig through the log files, or if you have to, the log files for Naemon are not really complete, because they should log once for every object that enters downtime. And when that downtime starts and when it stops, but it doesn't log the stopping part. It doesn't log the duration. So the user story here is that it should be easy to get. Oh crap! That's a completely different user story. Because of copy and paste, I have failed at that slide. So the user story is that it should be possible. It should be easy to leverage the power of really large data warehouse systems and data mining systems like Crystal Reports, or I don't know. I usually just blank out when people start talking about it, and then I start listening again when they tell me what data they want. The data that they want is always the data that that Merlin already puts in its report data tables, which is okay, state changes. So it streams host and I wrote it down. I didn't have to think. Host and service state changes, downtime, downtime start and stop, like process start and stop events from Naemon. Those are the things you need in order to be able to produce reliable reports of how long has this system been in this state during this period, and how much of that time are we not really sure, how much of it was scheduled, and how much of it was not. Those are the things that you want in a report, that you can, like, oh, we had 99.99995 uptime. In order to get that number, you need to know how much of it was scheduled maintenance and things like that. So this builds on top of existing interfaces, just like the performance data. It provides excellent performance, of course, because, well, I'm a performance fanatic. It allows using extreme performance data warehouse software to store the possibly huge amounts of report data. We have some customers with like report data database tables that have, I think the largest one I saw was 260 million entries for 4 months. It starts getting, it's not really that fun anymore. It's too much. Yeah, maybe you recognize this. This is the way we build most export things in Naemon. So something just hooks up to the nerd channel, the nerd radio, and says, give me this, I want it. Say, yeah, okay. Pass it off, and then you ship it on to the data warehouse. This is more or less how Merlin does it as well. Is anyone here familiar with Merlin, by the way? I feel I mentioned it a couple of times now. No? You are? Oh my God! Christian, it's so awesome. Okay, Merlin, you just Google it. We're running out of time here, and I'm getting hungry. It's a system for adding redundancy and load balancing, check distribution and load balancing to Naemon systems. It used to work with Nagios as well, but I don't think current versions of Merlin actually does. So yeah. All right. That's about it. Does anyone have any questions right now?
Did you bring the lightsaber?
Yeah, I did, but I broke it. No, I didn't. You know that there are actually lightsabers. They're really, really expensive, and you have to have them hooked up to a very strong power source. But when cardio surgeons do like heart surgery, they can cut you with a laser scalpel when we need to cut blood vessels and burn them at the same time so you don't bleed out and die. That's basically a micro lightsaber. The flame is about, well, the blade is about this long. I still think it's awesome. You just need to take that and scale it up. So as soon as someone invents a portable nuclear power plant, yeah, we're game. Oh yeah. Yeah, remember not to cross the streams. That could be really bad. Portable Chernobyl. So, if you have any questions that you figure out later, you can email me at ajeric79@gmail.com. You can visit naemon.org. If you want to watch this video from Ericsson, where they lay out their plans for how they're going to build a data center that we're going to monitor with Naemon, you can do that. It's very markety, not very technical. I actually didn't watch all of it because I got bored. But still, it's a pretty interesting project, and it's very interesting case study. Or you can just talk to me. I'm really not that dangerous. I tend to get drunk and fall asleep, so that's about it. Questions? No? Then thank you for your time.